It's a pleasure for me to be with you today, and I'm always thrilled when people want to learn about how to make buildings more resilient to wildfire or fire in general. It is just sad that it's on the backdrop, of course, of the fires in California. Some of them still burning. We're still learning about the consequences of those. But the more we learn, the more we're prepared, the less we will see disasters in the future. And I hope through my presentation here that I can help you be more prepared in your work going forward. So let's dive into it. When we look at wildfires over the years, there is no doubt that they have gotten more intense and more fires, more acres are being burned. These are some data that I normally show, and you can see from 83 to 99, we had an annual average of 2.9 million acres burning. And from 2000 to 2020, it's 7 million acres. And I think all of us realize when watching the news, etc., that there's almost not a month going by without we hearing about wildfires somewhere. And the catastrophes, Lahaina a year and a half ago, and now LA, they unfortunately keep happening. So one thing is wildfire, and when they happen out in the wild, that's the name, wildfire happening out in the wild. If it happens, we see a lot of really big wildfires, for instance, in Alaska, that we don't hear that much about because they're not impacting people in the same way. But what I really want to focus on here in my presentation, and I think this is also really relevant for the fires that we saw in California right now, that is the wildland urban interface. And this is where our built environment truly intermingle with the wildland. And it can be both with houses spread out over a big area with some distance between them. It can be like here where the houses, it's a development out in the wildland. So the edges of the development abuts the wildland. And it can be really tight neighborhoods as well that abuts wildland. And I think it's just really important to keep this in mind, because this is where the disasters tend to happen. Because when the wildfire meets the wildland urban interface, this is where we suddenly have a change of the fire. The fire goes from burning natural fuels to suddenly burning our built environment. And this is where we can have an event turn into a disaster, as we saw in Lahaina in Hawaii, and as we've seen in Los Angeles, California here recently. And why is that? Why do we see these disasters? What is it that happens? And to understand that, it is really important for everyone to realize that every building we put into these developments is a very condensed fuel package. There's about more than 30 tons of combustible materials just in the structure. This is not with the inventory that people have. This is just what the building is built of. Then add to that what we put in for our furniture, decorations. Then we park a car, maybe two next to it, maybe an RV. Suddenly, we have fuel sitting here that is much more dense than any of the natural fuel that we see out in the wildland. And therefore, what happens when the wildfire comes into these built environments, it starts igniting the buildings. And then those buildings burn, spread the fire to the next building, the next building. And suddenly we have transferred from a wildfire to a conflagration where it's the buildings burning and no longer the wildfire. So what is it that we need? We need fire resilient buildings and structures in these areas. This is a photo that one of my colleagues took after the fire that went through Paradise, California. And as you can see, there's nothing left except what was non-combustible: the chimney, the metal frame of the car, metal frame of it looks like some shelving that was in the garage. Everything else is gone. And that is what we also see in the pictures that come out of California now. Devastated building after devastated building with nothing left. And that is because, as I said, these buildings are such a condensed fuel package. There's so much in them that can burn. So if we don't want this to happen, we have to make sure that they do not burn. And in order for us to do that, we have to understand what is it that happens. And you know, I've been at NFPA for 7.5 years, and I'm a structure fire person. I've always, in my previous career, it was all about fire starting on the inside of the building, and how to prevent that and prevent that from burning down the entire building. When I came to NFPA 7.5 years ago, I started learning about wildfires. And what I had always thought in my mind when I thought about wildfire, I thought about this, you know, wall of fire moving through, burning everything. And that was what we had to make the buildings resilient against. And I have this fabulous colleague at NFPA, Michelle Steinberg, our director of wildfire. And she educated me and said, no, Birgitte, that is not the threat to our buildings. The biggest threat are the embers from these wildfires, because they ignite up to 90% of the homes that burn down in a wildfire. I think you've seen it also in the videos and pictures coming out of California from these recent fires, how you can just see those buildings are showered with embers. So what we really need to make sure is that when we build buildings, if they are being exposed to these kind of ember showers, they don't ignite. Because if you imagine this whole neighborhood is now being showered with embers from this huge wildfire that is happening out in the wild that we are abutting, we're not just igniting one house. It's not just one house being showered with this. It's hundreds of houses. And there is no way the fire department can show up and put out all these fires. So we have to make sure that the buildings don't ignite. And now I want to see if this works. I want to share a video with you that was made by the Insurance Institute for Business and Home Safety, which shows how embers can ignite buildings. So let me see if this works. So hopefully you're seeing a video. If not, I expect somebody to shout at me. They here are creating the embers for their experiment. And what they have here is two buildings that are more or less similar except for the outside. The house on the left has traditional cedar shingles. It has PVC gutters. It has wood shingles, wood mulch around the building. The one on the right has non-combustible siding. It has aluminum gutters, and it has a 5-foot non-combustible zone in the planting around the building. And as you can see, if you look really carefully, there's embers being sprayed on both of these buildings, the same on each building. And you can see a very, very different behavior of those two. The one on the right that has where the embers just are landing on the rocks next to the building, nothing happens. The one on the left, where the embers are now landing on mulch to start igniting, ignites the siding of the house, then the siding of the house starts burning. It goes all up under the roof. It is under the front porch, etc. As you can see, a really disastrous effect from those embers. And if that movie had continued playing, we would have seen that the building on the left would have burned down completely without intervention, while the building on the right would still be standing. That is the difference that we need to see out in the wildland urban interface. So where to go and find information about all this? Well, the Insurance Institute of Home and Safety is one of the places, and in my last slide will show one of their websites that I do believe you should go and check. But I also think it's really important just to look at not just the building, but what's around it. So we have to make the building safe from this, but we got to make sure that when those embers come in and they land around the building, there's nothing to ignite. So, this is a checklist for homeowners for what they can do in order to help them. It's all from our website, from NFPA's website, called firewise.org. And it's really about securing that nothing ignites as those embers come in. And the immediate zone, 0 to 5 feet, as you see here around this building, is key. This is where things need to be non-combustible. Don't have the mulch, don't have the plants that burns easily, don't have dried out wood, etc., wood pile, or even a fence, wooden fence coming into the building. Those can act as then places where the embers can start a fire, which then can impact the building. So this is where to start looking at it, and then look at the rest of the property and start taking care of that, making sure that you have a piece of property around you that is fire-wise. So let's look further at what we also need to think about. We need to think about fire resilient planning. So where it's great to look at one building at a time, that is truly important. It also is important that when new developments are being built, because we will see more and more developments being built in the future out into the wildland, that the risk of wildfire needs to be part of the planning and design decisions. It cannot be an afterthought. It has to be right up front. And I always like to compare this to, housing developments like high-rise buildings. This is just as you take 100 apartments and put them out in 100 separate buildings. Evacuation in case of fire is critical. Here's not people running downstairs from high-rise buildings. This is where people getting their cars and getting out. And we need to make sure that there's roads and so on that can actually take the traffic from people leaving the area. And then, just like if you were designing a high-rise building, you want to make sure that if there was a fire, it stays in that one compartment where the fire starts. We also need to make sure that these areas that we build, that fire spread between homes is prevented in the same way and is not allowed to spread from building to building. And it's a completely different ballgame when they are ignited from the outside and it's the entire building that's burning. This is not just the fire inside a building that cannot spread to the next. No, this is an entire house on fire, and that really takes something to prevent that from spreading to the neighboring building. It takes more distance than what you see in the photo here. So in addition to thinking about this, it's not just, oh, I've done this and we've built this great neighborhood and now we move on and just leave people to live in it and that's it. No, this is continuous action from the homeowners as well. They need to be engaged because we need to interrupt the fire's path. If they don't continue taking care of these areas, well, then suddenly we will see combustible things up against the buildings. We will see a lot of dead shrubs and so on there that has not been removed. So we really encourage these areas to participate in Firewise USA. That is residents, it's voluntary. They're working together to really help do the things that are necessary to interrupt the path of the fire. And it's amazing how just small changes can have big results. And literally the thing we're aiming at here is that if a home doesn't ignite, then it won't burn. That's what we're trying to work towards. There's also places you can go and find information. So let's dive into the codes and standards, because some of you are like, well, don't the codes and standards take this into account? Yes, there are wildfire codes and standards. This is NFPA 1140, the standard for wildfire protection. There's also an ICC code for wildfire. And in California, there's chapter 7A on wildfire prevention. There are these tools available. What often is lacking is enforcement of these, and implementation and enforcement of these. We know what to do. We know how it can be done. The information is here, but it needs to be implemented and it needs to be maintained. This is all about, fire protection and emergency services infrastructure in the wildland, rural, and suburban areas. We also, wildland fire management practices and policies, and the methods that you need for assessing the wildland fire ignition hazards. What is it that we need to prevent from when the embers come in? And then it also is job performance requirements for wildland fire positions that you can find all in NFPA 1140. But as I said, also the ICC code or California's Chapter 7A will provide information that is very useful in the design phase. And I want to just end up with this here from the Insurance Institute for Business and Home Safety. They have done so much great work on wildfire resilience. And I would strongly encourage you to go in on their website, wildfireprepared.org, and look at that and look at the recommendations that they give. It really gives all the, talks about fire resistant siding, talks about the 5-foot non-combustible zones, etc. It really provides all that you need in order to build buildings that are resilient to wildfires. And that was my last slide.
Thanks, Birgitte, especially for jumping in. I know you're pretty busy nowadays, talking with lots of groups. So, we've been talking about this for a while too, in the Passive House community, of course, and kind of for my personal journey in wildfire. My father's home burnt down in the Oakland Hills fire. That was 3,800 homes in 1991. So unfortunately, very familiar with these massive fire events that can happen in our neighborhoods and our homes. I lived up in the mountains. I live up in the mountains for quite a while now. Built a passive house up there, and what you're looking at is the Cameron Peak fire, which is the largest fire to date in Colorado. It's like 220,000 acres, and it burned right up to our property. When I was building my first passive house, I thought a lot about fire resilience. And first, especially after the fire, the Marshall Fire, which burned about 1,000 homes in Boulder County 3 years ago, we've been talking a lot about the why we need to be building fire resistance. I think we're past the why part, and we can jump kind of onto the deep side of the how part of it. So I'll go through a lot of hows today on what we're working with and exploring within our own practice. And I just wanted to take this quick shot is that, everybody says, like, you'll go into comments everywhere. Everybody's out, build your house out of concrete, do all, have nothing burn on the outside. That's actually not enough. In fact, there's a lot of concrete houses that do burn, or in this case, stucco houses. And I wanted to grab this shot because here's a reporter that was standing in front of these houses burning during the fire reporting that we were all probably watching at some point. And I noticed that this fire right next to this house that burned down was just starting to catch on fire. It looks like a stucco house. Guess what's catching on fire? It's the window frames. And those windows are going to fail, and the fire is going to get inside that building. And most likely that house is going to burn down too. So we're seeing houses burn from the inside out primarily, even no matter what they're built with. So want to talk about, like, we're really good about systems thinking in Passive House. This is a perfect example of where we can apply that systems thinking to fire resilience. And after the Marshall Fire, talked a lot about the idea of building forward, simply because there's no going back. A lot of people wanted to get back and kind of have their lives like it was before. I think in this time of climate change, the reality is that we're not going back, and we need to be prepared for this everywhere, especially for fire rebuilding, but in all our communities, as Birgitte expressed in very clear format. So the framework needs to change, and Passive House, I think, and climate adaptive design is very much a part of that. So we do think about how Passive House can be survivable in extreme environments. Fire conditions are kind of the next step of that, or the next level of that. So outside of just the fire materials for the holistic design and how those materials are applied to the building, and the actual design process around passive house works very well with fire hardening. And just quickly, here's a quick list. I went through kind of why passive house is really primarily a good fundamental start in fire resilience. We have the thermally protected windows, of course, triple pane most often. That's a fantastic place to start avoiding egress of fire embers in some cases, but often just the flame itself can break glass from a house next to it. Airtightness, we're seeing lots of smoke damage happening to houses. So of course, passive house does a great job of being sealed up, especially once you turn off the ventilation system to protect the house from smoke damage. And we're going to see a lot of smoke damage stories coming out of the Los Angeles fire, I think. And then you add proper siding, roofing materials, of course, that's pretty obvious now at this point, onto our houses. And then once, as Birgitte also mentioned, once we start building kind of in a neighborhood scale or a scale where each building protects each other, I was just talking about that domino effect where if you pull one or two dominoes out of there, you start protecting entire communities besides just your own particular home. So it's a collective action, at least in the condition of a large fire event. And then, of course, form factor, we talk about form factor, all this other good stuff, which we covered previously. But I won't go over that today. I'm going to go over actually kind of how we're implementing this in wall sections and things like that. So the challenge is taking that systems thinking and then thinking of a passive house as being hardened for climate and resisting moisture, mold, all these other things for decades, but also at that moment event of a fire event, that it's also prepared and hardened for that. So that means that we're dealing with both vapor control, moisture control, icing, all these other things, as well as long-term rot, as well as containing embers at the moment. So we'll take a quick look at those two competing interests and how we approach combining them. First thing is, don't do dumb things. Don't put in products that are going to be either vapor closed, so your building's going to rot, or going to burn really quickly. That starts often with what we put in the wall cavities and clad the building with inside. So I like to think of it as more than just like cladding it in fire resilient materials, but having fire resilience and vapor open capacity throughout the entire building process or design. And then for my first house that I designed about 10 years ago, 11 years ago now, up in Colorado, what we did was wrap the entire building in mineral wool board. And then that board was also the rain screen, was also vapor open. So we had good, control of moisture buildup within these super thick walls, which was a crazy new idea back then in the day to build passive house. Doesn't seem that long ago, but now at least it's quite normal for us, at least. And at the same time, with the mineral wool board and the roofing, metal siding, fiber cement siding, we have a fairly hardened building with a very simple form factor. So in my mind, this is a pretty well protected building generally. But I would say it's a good start using passive house methodologies. Moving on to kind of a better process, or kind of what we're working with now, is that this is, for instance, a client in Southern Colorado, really steep site, not steep so much, I was going to say much more brush intensive, going right up to the house in all directions. So how do you defend? There's no real defensible space beyond 20 feet for a house like this. So again, we have the simple form factor. In this case, we're using B public panels manufacture panels down in New Mexico. But they're, they're good. They're full of cellulose. There's no place for fire to propagate necessarily within the structure itself. And then when we looked at the design process of this, how do we harden this structure? We actually looked at the ventilating, the cladding, and the roof systems like that, and everything is kind of doubled up. So we do have an air gap between the panels and our fire hardened exterior space. And the airflow is just coming from one source, and the source is going to be, if you see this little red arrow down at the bottom, it's going to go through a single inlet going through what's called a Vulcan vent, which is a vent that will close completely during a hot fire event. So most of the time for the lifespan of this building, and hopefully there won't be a fire there, it's going to have air flowing around the entire cavities between the roof and the walls, and prevent moisture buildup. But at that one-time event of a fire, the whole system completely closes up. Windows are well protected, of course, and over insulated. We're using aluminum clad timber windows. The roof is actually double roof. So on top of a panelized roof, we're going to put an air gap, and then we're going to use another layer on top of that and put something called polystick FRP membrane, which is a fire resilient peel and stick underneath of the metal roof, so that conductivity of embers on top of the roof can't transfer into the superstructure itself. So that's kind of a better way we're thinking of looking at fire resilient design in the detailing. For our restore projects, which we built 3 of these out in Superior, Colorado so far, that these are fire replacement homes for fire victims. And that takes it to the next level in the sense of fire hardening, where we have the entire homes layered in that 2 inches of mineral wool on the outside. These are fairly tight lots, so we had to have relatively thin walls. So we're just using cellulose and mineral wool primarily. Cladding is either stucco or fiber cement again. Fortunately, a lot of these products are carbon intensive. So when you look at your kind of carbon calculation for your building, it's not always the most carbon effective, but certainly the most long-term effective in fire resilience for kind of the lower cost processes. We did end up doing a double roof system again with the polystick FRB with a metal roof on top, and then underneath we do have a ventilated cavity. So this is a code compliant, well ventilated assembly that again is going to be quite fire resilient. Moving on, the kind of our most exciting project now, and this is what I'm going to call best practices for our evolution so far in fire resilience. This is a lot that actually did get burned down in the Cameron Peak fire right across the valley from where my home is. If you remember that big blob of black, say that 5 times over. This was built right in the middle of that scene. So fire resilience is the first thing we think about, but also think about the carbon impact of our construction too, along with implementing passive house. So in this case, we're using this Eco Cocoon straw panelized material. And Eco Cocoon right now it's made in Europe. We're hoping to see a factory or 2 pop up in the United States in some time in the next few years. But essentially, it is a fire, I'm not going to say proof, but really fire resilient wall system up to 120-minute rating, at least European testing methodologies. So feel quite confident in what it does. Is it's packed so heavily that there's no air to support any burning inside the wall system itself. So after an hour of direct flame, it primarily just chars, and because it's so thermally unconductive. It doesn't let too much heat into the building itself. And again, the idea of the letting the vapor openness of the building still takes precedence for most of its lifetime. So in this case, we actually provided a exterior mildew-resistant sheetrock product over the panel to the exterior. And then we wanted to use a stucco product, but we use a product called mortar vents. It's a rain screen that basically you can nail onto your wall and then put your stucco over there. So we do have an air flow through that. And if we do have any ember issues, we're going to have stucco on one side and this fire resilient sheetrock product on the other side. So the straw wall itself is going to be completely vapor open, but fire proof essentially. The roof, we again did the second double roof system, where we have our typical standard plywood roof over our I-joists, and then we have an air space, and then again the steel and fire proof membrane underneath of the steel. And then again, we're also using this Vulcan vent product to allow airflow through the soffit in through across the entire roof and meet the ventilation standards with a really fire, I'm not going to say fireproof, but as fire resilient as we can get so far. We're also applying shutters to this building and learning a lot more about shutter design around metal shutters and how useful they can be, especially where the building's most vulnerable to the upside of the house where the windows are most exposed to the vegetation. And the windows themselves are also going to be aluminum clad and over insulated with mineral wool board. So they're highly protected. And then this is an ever evolving part for us, is learning about products and applying them within our passive houses. It's taking a little while, but it's getting deeper, and I hope that more products will be coming online soon, and that we can share those products and experiences with them throughout our building. So don't put dumb things in, put smart things in intelligent ways, and build to passive house standards is right now one of the best ways I can see for us, hardening for fire, for smoke, for fire issues, but also for all kinds of extreme weather events. Certainly after Colorado's fires, we almost inevitably have flooding. And we, in fact, had more people die of flooding from fire after fires than we did from fires at a couple of events. So it's definitely a wake-up call that our buildings are needing to be built in kind of a new reality. So that's it for me.
Great, thank you, Andrew. Thank you, Birgitte. And thanks, everyone. Please keep putting questions into the chat. We'll try to track them at the same time as we start a conversation here for the next 15 minutes or so. So starting out big picture, Birgitte, and I'm pulling questions from a bunch of different places. So the question came up about the codes, specifically the codes in California and around fire protection. I'm just curious too, of course, about California, but the nationwide, in terms of, you referenced a few reference standards from NFPA and others. Like, what does the adoption in the building code look like generally? And on top of that, you mentioned it can be in the code, but there's a lack of enforcement. Who is enforcement left up to? And just if you could fill that scene out a little bit more and how we need to think about it.
Sure. So California definitely has been on the forefront of this, of course, with all the experience that they've had over the years with wildfire. the problem is that many other states, even states that do see significant wildfire threats, have not adopted any of the model codes on wildfire. And in the regular building codes, wildfire is not, it's not built in the same way, and especially not the information around how to take care of things also around the building. So we see Colorado after the Marshall Fire have definitely changed there. I've been working on adopting wildfire codes and so on, but it's shocking to us that so many areas do not adopt any of these codes to help make new buildings more fire resilient to wildfires. And then, of course, with the enforcement, I mean, that's always I mean, you can have the perfect code of standard, but if it's not being enforced, if you're not making sure that the buildings are designed to it, and more importantly, even built to it and maintained to it as well, as is a big part of this as well, then you don't get the safety that you are planning for. So it's a challenge that we have, and fire departments and others that go out and inspect some of these are not staffed enough to keep up with the developments that are going on out there.
And if I could stick with you for one more moment, talking about the layers of hardening, and we talk about it with Andrew in terms of the architecture, but in the building, but in terms of the landscape and the environment, you talked about the different number of feet away from the building and what needs to happen. I thought the analogy to a high-rise building and the compartmentalization was fascinating. And I'm wondering, like, are communities in California thinking about it this way? One could imagine, because in a building, a neighborhood environment, there are codes about what color house you can have in certain homeowners associations and what the landscaping needs to be. If there's a code and you have neighbor enforcement about fire prevention measures.
That would be. We actually see. I think we now have more than 1,000 certified, or not certified, but designated Firewise communities in California. So there's more and more communities that have an interest in working together for this kind of fire safety. And again, as I said, California has been doing things, especially the last decade or two, to improve the fire resilience. The problem is that we have so many old neighborhoods that were built way before there was anyone thinking about these kind of code requirements. And that is the case of what we've seen here as well. Many of those buildings were built way before we had any wildfire code requirements. And that is a challenge then to make sure that how can we ensure that existing buildings also are brought up to a level of resilience that is acceptable.
Yeah.
So but no, the analogy to the high-rise buildings, it's one I don't hear from anyone else, and I think it's so important to keep in mind, because in this wildfire we did not see many challenges with evacuation, but in other wildfires we have seen that, where hundreds of people living in a neighborhood with one road in, one road out, they're all trying to get out when they're being evacuated and they can't make it out. This is where it gets really deadly in those situations. So this is why I want to keep that front and center as well when designing these communities.
Yeah, especially, I mean, in California, Los Angeles with the canyons, right? We're
Yes.
talking to folks where they may be safe, but if something does happen,
Yes, then we got a
it's all
challenge.
very quick. Andrew, there's also speaking about layers of hardening, and there's a number of different questions on, different materials, and, how you think about it. We saw you put forward kind of like where you're going with it, but thinking about metal roofs, thinking about, versus Class A asphalt roofs, or thinking about mass timber, hempcrete, concrete enclosures we've heard folks speak to in various places, and just how is your mind processing all of this? And I thought if I
Yeah.
could too, I love the joining the building science of the vapor drive and openness, and how are we making a durable building and balancing that with the fire safety. And how do we do both things? Because it needs to be, and yeah.
Well, I think it's really, I find it disheartening that we go back to kind of, maybe it's an American mindset, that it's just a technology thing. It's not a technology thing. Concrete houses burn. It's a systems thing. And if you're a systems thinker, then you'll be successful in building fire resilient house. But if you're a materials person, you're probably going to leave critical things out of that equation. And that's what's going to kick you in your ass. I guarantee it. So yes, big concrete houses did burn in Colorado, no problem, with the wrong roof system or windows that weren't correctly done, with the vegetation that wasn't done, with a big deck next to that big window or sliding door that broke. We have to think within systems. So any good material is it's only as good as its weakest link. That's how we think in passive house thermally, right? And so we're pretty good from passive house training to think about those connectivities and think about how all those things work together. And Ken, certainly from your work with 475 in the early days, talk about like vapor control and the longevity of buildings and the materiality. So we often talked about like the foam-free building, and part of that was the chemical kind of loading of the buildings. And Birgitte talking about, like, we're loading these buildings with foams and plastics inside. They're torches. And so how do we like reduce that burning mass? So a timber building can be more effective than a concrete building if it's properly protected, both for the short term and the long term. So, and then of course we need passive houses or buildings that can handle when the power goes out and it's -5 degrees out, or when the power goes out and it's 110 degrees out. We need buildings that can protect us from massive smoke events. So we need to think about all those things as we talk about just materiality. So, it's not a one-trick pony when we talk about buildings. So my way of approaching it, at least, is like, how do we merge those together?
I would love to comment on that, because you're absolutely right. You have to look at it as a system and not just focus on one thing. Of course, it's great to have a shell that doesn't burn, but if you then have openings that allow the embers in anyway, it's going to burn. Or if you have a combustible window frame, or even a window frame that melts and the window falls out and the embers come in, etc., then it doesn't matter that the rest of the wall was non-combustible. I think I always find it interesting to look at pictures from big wildfires that's gone through Southern Europe compared to the US. In the US, you see there's only the chimneys left and whatever metal was there. In Southern Europe, you will see that the shells of the houses are standing, because most of these are made of heavy stone and with a tile roof. But the house is actually burned out from the inside, because they did not have the ember protection. It went in under the tile roof and then burned the house out from the inside. So again, it's not about one thing. It's about looking at the system and make sure that you think about all of these things together to create a package that is wildfire resilient. So it's more than just a material. It is systems. So I really like that, Andrew.
Going from systems, though, back, if I may, to materials, I'm curious, Birgitte.
Okay, fine. We'll talk about
No, we'll go back and forth. Well, so it is this like combustion loading, and these houses are packed with all kinds of materials and lots of plastics, as you mentioned. I'm just wondering, I mean, I just had this flash of this image of like East Palestine in Ohio, and the tankers that they burned off and all of the toxic smoke that was, poisoned whole communities. I mean, we have neighborhoods burning down that are loaded with toxic chemicals.
Yes.
How does that fit into the thinking, perhaps, or are codes speaking to that at all? Like,
Not yet. And that is something that we are starting to look at because there's no doubt that the smoke impact, from a wildfire have been significant. If we've seen that when that has come and hit even here on the East Coast. But when it becomes a wild and urban interface fire, when it's the building that burns, then suddenly it's not a natural fuel, it's a synthetic fuel we add in there. And there's been some measurements done that have shown some of the toxicants that are in this, and it can spread over big areas. So I actually really liked Andrew in his presentation was also mentioning the importance of having buildings that you can make smoke tight, because a lot of the people that are going to return to their buildings, to their homes that did not burn in LA will find that those homes are probably devastated by smoke damage. The smoke damage is a significant appreciated problem that we need to consider in all of this. And both in the acute situation during the fire, but also afterwards, the residue that it leaves afterwards, and the pollution that it leaves in the area. There's been some really great guidance on this that's been produced by the Chemical Insights Research Institute, has produced guidance on how to secure or help prevent smoke damage to your home if you're in one of the neighborhoods that are impacted by the smoke and not directly the flames.
yeah.
Yeah, and just to further that, of course, we have the passive houses are airtight with the ventilation system. And then I'm working on a Monterey house, and we know about that battery fire that's happening in Monterey. But we had another issue with the intake and for the ERV, I'm sorry, it's an HRV in this case. And I need to put a metal screen in on the intake side of it, like a metal filter for mist. It's called a misting filter. And I realized, oh my God, this filter is the perfect Ember resilient filter as well. So if you're not home, we often think, oh, in a fire, we can do this, this, and this. You're going to be evacuated, at least in my experience, sometimes weeks or days before the fire hits you. You can't be there to do anything to your house. So the house has to be kind of ready on the go. So, the kind of the evolution even more recently is like, how do we protect the ERV plastic cores from embers, and putting metal screens in front of them that could also act as just general particulate filters, but in the fire event, help reduce or eliminate that potential. So every little part of that puzzle is still being filled out, and there's more thinking to go, but it's that toolkit is going to keep growing. And I hope that other people have toolkits out there that we just have it at our ready to apply to buildings, especially in a hurry. When you're rebuilding, it's pretty chaotic for designers.
Yeah, great. So I wanted to stick with a piece of that, Andrew, for a second. And then I've got one other big question. So on the venting, it was an early question. The back vented rain screens, and then we've got the roofs. And I was happy to see you're speaking so specifically to that. And just, I don't know if you could reinforce your thinking behind that. Yeah.
Code doesn't help us right now because we have to ventilate our cathedral ceilings. So
What doesn't help us?
code for like
Oh,
cathedral ceilings, I'd
yeah.
like cathedral ceilings. Code is not made, you have to ventilate the top of your roof, and at least for cathedral ceilings. So we have to do all these kind of workarounds and expensive assemblies to achieve that. So I used to fight it, and now I'm just kind of embracing it and learning how to like integrate systems. I saw a comment saying Vulcan vents are really expensive. Yeah, they're expensive until you don't have a house. Also, you don't need a lot of vents to vent a facade or to vent a roof if you design it properly. Like probably our most expensive, nicest house only has one strip, 24 feet of 3-inch Vulcan vent for the entire house. That's not very expensive protection. And, when it's a peace of mind, and there's nothing worse to think that like you don't want your house to be growing mold and stuff like that. So that's the long-term health consequence. You also don't want the short-term consequence of smoke ingress, or when you leave your house, not that the worst thing is the psychological issue of my house is really vulnerable and everything inside of it is vulnerable when you leave it during a fire event. It's about the most sinking feeling to have.
Yeah.
It makes me feel a lot better that at least my house has a chance for survivability because I made these decisions early in the game.
That's a great point. So, in thinking about the events and the costs, and it's again this idea of, we shouldn't be atomizing things and just looking at them in isolation. In Passive House, it's a common trap to look at the cost of the windows or the cost of the ventilation system, but the whole system, what the cost of the whole construction is and how we can optimize that and get these important aspects in. And tying that then to one big question around insurance that came up, and this idea that people are insured up to a certain point, you can build back what you had more or less under the insurance policies, but doing better can be quite difficult. And I'm curious, from your experience, Birgitte and Andrew, like you're thinking about that or what you're seeing today with the insurance industry and what's possible.
I'll start out. There's been studies from Headwaters Economics that has shown that to make a building more fire resilient compared to building it where it's not, the cost difference is really not that big. And I don't think that will be what will be the problem with the insurance company. I actually think the bigger problem will be that if we don't do it, at some point there won't be insurance available. So it's going to be interesting to see what will come out from the insurance companies after this event. But because this is going to cost a lot of money to them, so we need to find a way where we can ensure that people get the incentives needed to build resilient buildings in place of they lost.
The cost thing is really interesting because from the two massive fire rebuild efforts I've seen from Oakland and Boulder County, people built much larger houses. And they didn't talk about the cost of that side, but when we talk about the 7 to 10% cost upgrade potentially to build fire resilient passive house, then it becomes the main issue. So it's more like a forced perspective, and that's not a building back, that's a building forward. But now I get to build my dream house. A lot of people do that, and I think that's great. But part of that dream is building a resilient,
a slightly smaller dream house,
maybe a smaller dream house. and that comes to good design and good urban. I think maybe we need to build less houses and more multifamilies, on some of these lots, and provide more housing and economic opportunities for people as well. So it opens a whole can of worms about the whole housing industry. But going back is probably not going to be the answer. And building affordably has never been a reality in California, regardless. So this is I think for California, especially with the temperate climate, I don't think there'll be almost any cost for building to passive house standards in that area.
Yeah, I mean, the cost optimization, which is going to vary us. I'll circle back in 1 second. Just one last, I think, question, Birgitte, regarding I was reminded about earlier comments and then later about this issue of setbacks and separation from buildings and codes and zoning, where in Seattle, they're working on, are getting certain allowances for insurance and insulation to go into the setback area. But fire marshals are really pushing back, and if whether a 5-foot setback between the property line and the building versus a greater setback or a few inches less, is that where the impact is? From your presentation, I would say no, but I don't want to, like, can we go a little tighter, but better?
No, I've seen out in the chat several comments around setback and so on, and most of the rules that we have in our existing codes were based on fire in a building and venting out and then to the other building. So therefore, that was sort of what we could accept for a distance between two buildings. As I was making the point in the presentation, if we have a whole house on fire, that is a completely different exposure. So if you have only 10 feet between the buildings, that neighboring building is going to go as well. That's the risk. So if you do want to build that close, that really speaks to the need for ensuring then that the whole building is not on fire. And somebody in the chat asked, is there research on this at this point? Not enough to say, well, what could you do if you want to have only a 10-foot distance between? Can that be done in any way? And if so, how? There's some research going on this that hopefully will be able to answer some of that, but it's not an answer I have yet. Somebody also commented out there that they went in on the wildfire prepared.org site and said, well, if I don't have 30 feet to the neighboring building, I can't get the plus rating, which, yes, that is the truth. But then go for the lower rating that you can get. Prepare as much as you can. Because when you have buildings that close, it becomes really difficult to make sure that you don't get this kind of catastrophic spread. So that's, I hope I didn't confuse more than help.
I think that was very helpful. I think both of you provided a lot of great information and certainly answered a bunch of questions that I had. And I should note for everybody that, this is, Andrew spoke about the Marshall Fire, which happened a few years ago just over a couple of winters ago, and how the Passive House community there in Colorado really came together and helped support how we could, thinking through and building back in a way that's looking forward and looking to greater fire resilience. And I know our thoughts are with the people of Los Angeles, and want to bring more resources and information forward in the coming weeks and months, and looking at different programming as we go, to be whatever help we can be to the folks there. And look, there's going to be the next wildfire and the next wildfire and the next hurricane, and on and on in our climate reality. So it's important that we keep building these resources together. So thank you both very much. Thank you everyone for joining today. I wish you all well. Have a great day.